A researcher cloned a GitHub repository this week, completely clean, not one line of malicious code in it. They opened Claude code to help set it up. 3 minutes later, an attacker had a live shell running on their machine with their own permissions, and the repository still had nothing in it that any scanner, any human, or the AI itself could flag as dangerous. This is real. It happened on June 27th. Mozilla's security research team, ZODIN, published it, and it connects to something bigger that most developers have not heard about yet, even though it is already sitting inside 2,388 companies right now. Let me walk you through exactly how the GitHub attack worked, because the mechanism is the entire story. The repository had standard setup instructions, run pip install, totally normal, but the package installed by that command was engineered to throw an error, a fake error on purpose, instructing whoever runs it to execute one more command to fix it. Claude code reads that error, sees the fix, and, because fixing errors is literally its job, runs it. That command quietly reaches out to a DNS record controlled by the attacker, pulls down a hidden value, and executes it as a shell command. Mozilla's researchers put it perfectly. Quote, Claude code never decided to open a shell, it decided to fix an error. The agent did exactly what it was built to do. That is what makes this so hard to stop. Once that shell is open, the attacker has everything the developer has. Environment variables, API keys, AWS credentials, Git tokens, the ability to install more malware and stay there permanently, and this is not limited to Claude code. The same researchers confirmed Cursor, GitHub Copilot, and Gemini CLI are all exposed to versions of this exact attack pattern. Now here is where it connects to something much larger. 2 weeks earlier, June 12th, a different security firm called Tenet disclosed an attack class they named Agentjacking. Same core idea, different entry point. Instead of a fake GitHub repo, this one uses Sentry, the error tracking tool that thousands of companies wire directly into their applications. Sentry has something called a DSN, a public key, intentionally public, sitting right in the website's own JavaScript code by design. Anyone can see it, anyone can use it to send a fake error report straight into a company's Sentry dashboard. So the attacker crafts one fake bug report, formats the fix section to look exactly like Sentry's own remediation guidance, same structure, same tone, indistinguishable. Then a developer or their AI agent opens Sentry to clear the error backlog. The agent reads the fake fix, trusts it completely, runs it. Just like that, game over. Here are the numbers, and they are not small. Tenet found 2,388 organizations with exposed injectable Sentry keys in controlled testing against real targets, not theoretical, actual organizations who agreed to be tested. The attack succeeded 85% of the time, across Claude Code, Cursor, and Codex, all three of the most widely used AI coding agents on the market right now. One of the organizations where this worked was a Fortune 100 company, a $250 billion enterprise. Their developer's coding agent had a live AWS secret key sitting in its environment. The attacker's test reached it, confirmed, documented. That is not a small business with no security budget. That is one of the largest technology companies on the planet, and their AI agent still ran the attacker's command. Why does this work even when teams explicitly tell their AI agents to be suspicious of outside data? Tenet tested that specifically. They configured agents with system prompts explicitly warning them to treat outside tool data as untrusted, to never run external commands without confirmation. The agent still executed the malicious payload 85% of the time. The problem is not a setting you can turn on, it is architectural. Models currently do not apply the same skepticism to data coming back from a connected tool that they apply to a message typed by a human. A tool response looks like ground truth, not like something that could be lying to you. Here is the part that should genuinely concern you. Whether or not you write a single line of code, when an attacker silently steals a company's cloud infrastructure keys and source code through a trusted developer tool, the thing they ultimately reach is not abstract. It is the database holding customer names, payment information, health records, whatever that company stores about you. Every one of the 2,388 exposed organizations has customers, has users, has people whose data sits downstream of a developer's laptop. And this is not happening in isolation. 10 days after Tenet's disclosure, the Five Eyes Intelligence Alliance, the US, UK, Canada, Australia, and New Zealand issued a joint statement most people never saw. Their exact words, "The timeline is not years, it is months." 5 national intelligence agencies together, telling the world that AI is about to dramatically accelerate the speed and sophistication of cyber attacks faster than current defenses can keep up. This was not issued lightly. Five Eyes agencies do not coordinate a joint public statement unless something has genuinely shifted. Here is the response from the vendor at the center of this. Tenet disclosed the Sentry vulnerability privately on June 3rd. Sentry acknowledged it and then said, in writing, that the underlying issue is technically not defensible. Their fix was a content filter blocking the one specific payload string used in the research. That blocks the exact proof of concept. It does not touch the underlying pathway. Anyone who crafts a slightly different payload walks right past it. This is not unique to Sentry either. Security researchers have since pointed out that Datadog, PagerDuty, and Jira, tools just as deeply embedded into developer workflows, carry the exact same structural exposure. Any service where an AI agent pulls in outside data and treats it as trustworthy is a potential entry point. This is not a story about one company's bug. It is a story about an entire category of tool that the industry adopted faster than it built the guardrails for. So what do you actually do with this if you are a developer using any of these tools right now? 3 things matter. First, never let an AI agent execute commands from an external tool response without a human reviewing it first, especially anything resembling a shell command or script execution. Second, audit every MCP connection your agent has access to, the same way you would audit a third-party library before adding it to your codebase. Tenet open-sourced a tool called Agentjacking specifically to help harden Cursor and Claude code against this. Third, if you run a Sentry, Datadog, or similar integration, treat your DSN and equivalent keys as something that needs monitoring, not something you can assume is safe because it is supposed to be public. The honest reality is this: AI coding agents went from autocomplete suggestions to autonomous systems that execute commands on real infrastructure in about 18 months. The productivity gain is genuinely enormous. That is exactly why adoption moved this fast. But the security model for trusting what an agent reads from outside sources did not move at the same speed. That gap is where 2,388 companies are sitting right now, and the number is almost certainly higher today than when Tenet published it. Subscribe to SynthOps, drop a comment. Do you use Claude Code, Cursor, or Copilot in your daily work? Has your team audited what your AI agent can actually reach? I read every single reply.